In this video, we will generate the trendline and polynomials of the first and second kind Chebyshev polynomials using combine and double factorial. Here we have the expansion, the Taylor series expansion, the expansion coefficients of the first kind, expansion coefficient of the second kind. Our value k will be from 0 to n, and our value for n is from 1 to 10. So data validation over the range from 1 to 10, because we're calculating up to the 10th degree. So we can start from 1 up to 10. And the value of k is from 0 to n. So this will be sequence n plus 1, comma, 1 column starting from 0, incremented by 1. So that at n equals 2, k value is 0, 1, 2. At n equals 3, k value is 0, 1, 2, 3. N equals 4, k value 0, 1, 2, 3, 4. At n equals 5, k value 0, 1, 2, 3, 4, 5. Now the first kind expansion coefficient. So this is the array formula. Minus 1 raised to the power k. That's the first part. Times the second part. Factorial n plus k minus 1. So factorial n plus k minus 1. That's the second part. And finally the third part. Combine n comma k. So combine n comma k. Then enter. We continue with the denominator. Now that we have the numerator, denominator. Denominator has two parts. The first part is factorial n minus 1. So factorial n minus 1. That's the first part. The second part. The second part is double factorial 2k minus 1. So fact double 2 times k. 2 times k minus 1. And enter. And we correct this. So we have three conditions of ifs. Starting with the first one. Ifs. First one is if k is empty, then 0. The second condition, if k equals 0. Then 1. The third condition, if k is greater than 0, then calculate this. So we fix this error, and we fix this error. Now we continue with the second kind expansion coefficients. Array formula. Minus 1 raised to the power k. That's the first part. Second part. Factorial n plus k plus 1. So factorial n plus k plus 1. That's the second part. The third part. The third part is combine n comma k. So combine n comma k. We have completed the numerator. Now the denominator. The denominator has two parts. So we start with we continue with the denominator. The first part is factorial n. So factorial of n. That's the first part. The second part is double factorial. So fact double 2 times k plus 1. And enter. Now we have to, if this is empty, if k is empty, this should be 0. So we correct this. So if k is empty, then 0. Otherwise, calculate. Now it's fixed. Now we can continue with the Taylor series expansion, starting with the second kind. So array formula, series sum. Now 1 minus x, so 1 minus x raised to the power k, where k starts from 0 incremented by 1. And the coefficient will be this range. And this first kind polynomial, this is array formula, series sum of the x, 1 minus x, so 1 minus x raised to the power k. So 1 minus x raised to the power k, where k starts from 0, incremented by 1. And the coefficient will be this range. And we'll chart this. Insert chart. And we use scatter chart. Use row 1 as header. Show the series, the trend line, the type polynomial, the degree 10th. For the label, use the equation. For the legend, position at the bottom. And now here's our trend line. We'll calculate this polynomial regression coefficients using LINEST. To do that, we'll complete the LINEST matrix. So we calculate this, we complete the LINEST matrix starting with the power. So we have power 0 to 10. So array formula of the x values raised to the power 0 to 10. Enter. Now we can use LINEST. LINEST data y and data x. And this is also LINEST data y and data x. And enter. So let's compare. We start from 1. At n equals 1, our coefficients will be 1, 2. So this is 1, 2. That is x and 2x. At n equals 2, coefficient will be 2, 4. So this is 2, 4. And negative 1. So this is negative 1. Coefficient of x cubed will be minus 3, minus 4. That's minus 3, minus 4. For x cubed, that's 4 and 8. N equals 4. So x to the 0, that is 1. X squared minus 8, 12. And coefficient of x to the 4th, 8, 16. N equals 5. That's x, 5 and 6. 5, 6x. For x cubed, minus 20, minus 32. For x to the 5th, 16 and 32. X to the 6, n equals 6. So coefficient of x to the 0, negative 1. For x squared, 18, 24. For x to the 4th, minus 48, 80. And x to the 6th, 32, 64. X to n equals 7. So coefficient of x, minus 7, 8. Coefficient of x cubed, 56, 80. Coefficient of x to the 5th, minus 112, minus 192. Coefficient of x to the 7th, 64, 128. N equals 8. Coefficient of x to the 0, 1. Coefficient of x squared, minus 32, 40. Coefficient of x to the 4th, 160, 240. Coefficient of x to the 6th, negative 256, 440, minus 448. Coefficient of x to the 8th, 128, 256. Coefficient of x to the 9, n equals 9. So n equal to the 9th degree, that is at x, 9, 10. So 9x and 10x. X cubed minus 120 minus 160. X to the 5th, 432, 672. X to the 7th, minus 576 minus 1024. X to the 9th, 256, 512. At n equals 10, the 10th degree. Coefficient of x to the 0, -1. Coefficient of x squared, 50, 60. Coefficient of x to the 4th, -400, 560. Coefficient of x to the 6th, -1020, -1792. Oh, 1120, 1792. Coefficient of x cubed to the 8th, -1280, -2304. Coefficient of x to the 10th, 512, 1022. This completes the use of the combine function, the double factorial, and Taylor-Maclaurin series sum of LINEST polynomial regression to generate the first and second kind Chebyshev polynomial.